King's rule integration. Say you want to integrate a function between a and b, and this function is f of x. Now what does this mean? This means that we have a function, and we want to find the area between a and b. Right? Now I can reflect this graph such that I've got negative a and negative b. And this right here is still going to be the same as this. So let's call this I. This is also going to be I. Right? Because all I've done is just reflected it across the y-axis. Now I'm going to shift the graph a plus b forward so that we align back to a and b. No, this is a... This is a... This is b. Okay? Sorry, this is a... This is b. What I've done is I've slid this graph sideways by a plus b, such that it aligns back with b and aligns back with a. Right? And again, this is still going to be I. So, this means I can rewrite I as I is equal to AB, this time f of a plus b minus x dx. How did I get this? I reflected it and I shifted it across by a plus b. So the function now becomes f of a plus b minus x dx. Right. And I know that these two integrals are equal. Let's look at an example in which this is useful. Integral pi over 2 0 of sine x over sine x plus cos x dx. Okay, let's use this formula we just learned. We have f of x, right? And in this case, f of x is going to be sine x over sine x plus cos x. Now we want to find what f of a plus b minus x is. And that is going to be pi over 2 plus 0. So pi over 2 minus x is the same as sine pi over 2 minus x over sine pi over 2 minus x plus cos pi over 2 minus x. All I did here is just substitute in pi over 2 minus x. So this integral is the same as pi over 2, 0, sine pi over 2 minus x, sine pi over 2 minus x plus cos pi over 2 minus x. And remember, if you're wondering why these two are the same, it's based on what we did right here. We just reflected the graph and then slid it forward by a plus b. Okay, now we can see that sine pi over 2 minus x is the same as cos x. Cos pi over 2 minus x is the same as sine x. Sine pi over 2 minus x is the same as cos x. Okay, so now notice we have I is equal to this and I is also equal to this. So let's add these two together So 2i is equal to pi over 2, 0 sine x plus cos x over sine x plus cos x dx. So 2i is equal to, shift pi over 2, 0, and look, this just cancels out and just forms 1 dx. So 2i is equal to integral pi over, and what is the integral of 1? It's just x. Now we substitute pi over 2 and substitute 0. This just gives us 2i is equal to pi over 2. So I is equal to pi over 4. And this is our answer. So we know that the answer is pi over 4. However, there is another very slightly different way of doing it, which is a u substitution. Let's substitute x is equal to pi over 2 minus u. So dx is going to be minus du. So we have I is equal to, substituting pi over 2, 0 for u, and do the same for 0, and we get pi over 2. And then we have, substituting this for x, we have pi over 2 minus u over sine pi over 2 minus u plus cos pi over 2 minus u. And we have minus du, because I've just replaced the dx here. And we got minus du. Now, because there's a minus here, we can flip round the limits. And notice how we have the same thing when we applied King's rule, but this time with a u instead. So again, this simplifies down to cos u over sine u plus cos u du. And because this is just a variable change, I is also equal to pi over 2, 0 sine u over sine u plus cos, x dx. I just changed all the variables into an x. We have this. And, there's supposed to be a cos at the top. And again, we're back to what we had before we applied King's rule, that the integral is also cos x over sine x plus cos x. We can add it to this integral, and everything will cancel out to get 1. And again, we'll get our pi over 2 answer. Okay. Thank you very much for watching. If you struggled with this, I strongly recommend you watch videos on graph reflection and graph translation and u substitution for integrals. Thank you very much.